So we are more complicate the ways to move. So instead of having roll a die, pick a card, or dealt a dealt a card, and we also have toss a coin. So those 3 cases. Instead, what if we are looking at something like let's see, probability of winning the lottery ticket or things like that. So we are moving to a more complicated way to do it. So we are working on counting principle. So as I said, if you know how to count, you're like 90% done in probability. So counting is important. So the first counting is called fundamental counting principle. Fundamental counting principle. Fundamental counting principle. Okay, fundamental counting principle. So fundamental counting principle, it says, okay, we have many groups. So here's a group 1, here's a group 2. So you went out trick-or-treat last Sunday, a few weeks ago. So here is that homeowner has 2 baskets. Here's a basket for chocolate. Here's a basket for candy. Okay, so we have M&M, we have a Reese's. We also have
Twix.
Okay, what is it? Egan, you say something. We have a Twix, okay? We have Twix and things like that, okay? We also have Musketeers and things like, I don't know. There are just so many, okay? So out there, Hershey's, okay, HH. I want to write different letters here. So we have many things. And the candy, we have let's say we have Lollipop. We also have okay, whatever. Here is candy 1, here's candy 2, whatever that is. Okay. Now the homeowner says you are able to pick 1 from each basket. So you are picking 1 from here, and you are picking 1 from here. So I pick 1 here, Hershey's. I pick 1 here, some candy, C1. Okay, or maybe I can pick M&M and I can pick anything else. So fundamental counting principle says, how many ways can you pick a chocolate? 1 chocolate. There are 5. So we have 5 ways to choose. How many ways can you pick a candy? There are 3 of this. So I have 3 ways to check. Fundamental counting principle says you multiply. So far, we don't add. Everything is multiply. So that's what it says. If you choose 1 item from group of M and you choose 2nd item from group of N, then combined together with the 2 item choices are M times N. Fundamental counting principle, multiply, okay? Now, fundamental counting principle, multiply. Multiply, always multiply. You get confused, multiply. Forgot, multiply. There's no addition, subtraction, division, nothing like that. Always multiply. This is the first obstacle of know how to count, okay? So this is the first type, fundamental counting principle, fundamental counting principle, always multiply. Here is a number of choice from one group, here's a number of choice from another group, multiply. If I have another group, so chocolate, candy, and then I have a drink. So there are 2 types of drink, here is multiply. You keep on multiplying from each of the groups. Do you understand this? Fundamental counting principle, keep on multiplying, okay? Fundamental counting principle, always multiply. Number of items from each group, okay? Number of items from each group. Let's have an example here. Okay, oh, there are a lot of examples here. So let's try some here. Example 5. Greasy Spoon restaurant offers 6 appetizers, 14 main courses. How many ways can person order 2-course meal? All right, so we have a group of appetizers. We have a group of main courses. There are 6 appetizers, 14 main courses. Fundamental counting principle says multiply. So you have a calculator, 6 times 14. What number we have? Kate, do you have a number? Leslie?
84.
84? 84? So there are 84 ways to choose 2-course meals. Fundamental counting principle. Are we okay with this? So it's your turn. I want you to look at problem 68 and 69 of that page, the bottom of the page. All right, go ahead and try and see how much you understand fundamental counting principle. All right, the important part of a fundamental counting principle is know how to find groups. So what are groups? Okay, so here's one group, here's another group, here's a group number 3, here's a group number 10, and so on. So make sure you are able to separate groups. Okay, so let's do number 68 together. 68, let's see. Aaron, how do you separate groups for number 68?
I'm not really sure yet. I'm trying to learn.
Problem 68, you know how to separate two groups. Michael, how do you separate?
Oh, wouldn't it be 10 over appetizers times 15 over main?
I'm sorry, what did you say you are dividing?
I don't know. Never mind.
Okay, so we are looking at the counting in here. It's just a huge number, okay? This is not probability. We are looking for how many ways, okay? So it could be millions and thousands and hundreds and like a large number, okay? So the fundamental counting principle says we first have to split into the groups. So here's a group of chocolate, here's a group of candy, here's a group of socks, here's a group of t-shirts and things like that. So we have many groups. So first split the groups, and we are looking for a number of items from each group. Fundamental counting principle says you multiply all this number of items from each group. All right, so Egan, what do you think?
Wouldn't it be 10 times 15?
Okay, how'd you get 10 times 15?
10 appetizers and 15 main courses.
Okay, so we have appetizers as one group, main courses as another group. We multiply. This is what the fundamental counting principle says. So there are 150 ways to order. Are we okay with this? Aaron, you okay now? All right,
Yeah, thank you.
okay, let's move to 69. Let's move to 69. All right, so it's a really long way of writing. And again, it's a fundamental counting principle here. Fundamental counting principle. Kayla, what do you think?
You say Kayla?
Yep, I say Kayla. Yep.
I put 15 over psychology times 9 over social science. And when I multiplied, I got 135.
Very good, very good. So we have a group of psychology, and we have a group of social science. Here's a 15, and here's 9. You multiply together. What was 15 times 9?
135.
135.
Okay, 135 ways to choose a 2-course schedule. Okay, question. And then we are adding more groups, okay? So here is a psychology, here is a social science, you are adding math, you are adding science, you are adding English, computer science, and arts, you know what I mean? So we are adding more. So we have called a fundamental counting principle in general. So you're adding more groups. So number of ways of each thing, okay? So you have 2 groups, 3 groups, 4 groups, and so on. So let's try with this 2 examples here, example 4 and 6, next page. Okay, example 4 and 6. Let's see if I can make it big so we all can see it. Okay, so you have a workbook, so you're able to read from your workbook. So example 6, pizza can be ordered. Pizza can be ordered, and there are many groups. So let's write it out. First It depends on size. The next one is crust. The next one is toppings. And that's it, right? So there are 3 groups. So how many size? It's a medium or large. Crust, thin, thick, or regular. Toppings, beef, sausage, pepperoni, bacon, and mushroom. So it has 5 toppings. Fundamental counting principle says number of items from each group, you multiply that. So we have 2 times 3 times 5. You have a calculator. 1 topping pizza can be ordered. There are 30 ways to order. Is that true? Okay, 30 ways to order. All right, next example for 7. Next example for 7. Car manufacturers now experimenting with 3-wheel cars for 1 person. Okay. So there are many of those groups. Suppose you can choose car from choice of colors. With, without AC, electric or gas powered, with, without onboard computer. Okay, so there are like 4 groups. So let's write it out. 1, 2, 3, 4. So first groups are colors, AC, power, gas or electric, and then onboard computer. Okay. So there are 9 possible colors: with, without AC, electric or gas, with, without onboard computer. Apply. What are they? 9 times 2 times 2 times 2. You have a calculator.
72.
72 ways to choose. Any question of a fundamental counting principle? Okay, if no question, now it's your turn. Problem 73 and 74. Go ahead and try. And then there are more, right? You have the workbook has more questions. At least we can try this together. 73 and 74. Okay, so let's do it together for number 73. I should done 71 and 72 first, but that's okay. Let's do 73. All right, so who can do this problem here? Connor, you want to try 73?
I had trouble with this one.
You troubled with this one. Okay, so let's move to Egan. You want to try this?
Yeah. So we got the 10 possible colors. And then they said the air conditioning, the power, and the board computer are still applied. So it'd be two.
Wait. Hold on a second. We are doing 73.
Oh, sorry.
Are you doing 71? Okay, so we do that later. 71, that's in the next page. Okay, 71 is the next page. I kind of messed up with this problem order. But let's start with the 73 because this page was coming before. Let's see who can answer this question. Hold on a second again, okay? Michael, have you?
Sorry.
Oh, Kate, you want to try? You can try.
Yeah, so I did 3 times 15 because there is a red, blue, and black ink, and then there's 5 different types of tips. So I
Okay.
did 3 times 5, which is 15.
3 times 5, which is 15. Excellent. That's what you do. Very good. So we have 2 groups. One is ink. Okay, so we have a red, blue, and black. And the other is writing tips. It has extra bold, regular, fine, and micro. There are 5 of this. So together it's a 15. Excellent, Kate. You did an excellent job. Let's move to 74 then. Kyle, what do you think about 74?
You do the main times the starter times the dessert, which is 3 times 6 times 5
Okay.
equals 90.
Okay, times dessert. Okay, so we have 3 main, 6 starters, and 5 dessert. Okay, so 3, 6, and 5 combined together. What number you have?
90.
90. Okay, starters. So together 90. So we have the group of main courses, 6 starter choices, and we have 5 options of dessert. So combined together, so we have 9 different ways to order the meal. All right, very good. Okay, then I move to 71 and 72 here. So then I move to 71 and 72. Okay, Egan, you did the 71, right? Accidentally, but that's okay. Let's do it.
I actually did 70. I didn't do 72.
You didn't do 71?
No, I didn't do 71. I did 70.
You did 70. 70 was, where's the 70? Okay, I messed up with this order. Where's the 70?
It was on the first page. It was the one that had to do with the car manufacturer.
Oh, I see. Okay, so shall we do 71 and 72 then? Okay, so I give you a couple of minutes. So right above 71, you have an example, so you can have something similar to it. Okay, 72, something we need to think about it. So go ahead and try 71 and 72, and let's do it together. So it's all about the fundamental counting principle, meaning, are you able to make it into group? So once you have groups, are you able to multiply the number of items for each groups? Okay, so try this, 71 and 72. Okay, so let's do problem 71 first. So I kind of put this example 4. It's because it's a similar to 4.4, slightly different questions in here. So in your notebook, you do have the multiple choice test with 10 questions. Now this time it is multiple choice question with 6 questions. Okay, 6 questions. So the question is, how do we make into the groups? Okay, so here's how we can make groups. There are 6 questions. So question number 1, question number 2, question number 3, question number 4, question number 5, and question number 6. These are groups here. Each question has 3 answer choices with 1 correct answer per question. If you choose 3 choices and leave nothing blank, so you have to choose A, B, C. Okay, you can guess it. How many ways can you choose? 3 ways answered question number 1 is A, B, C, 3 choices, leave nothing blank. 3 choices for question number 2. It's all 3 choices. Fundamental counting principle says we multiply. So it's not 3 times 6. It's a 3 to the power 6. It's a huge number. Okay, what's 3 to the power 6? We have 729 ways to answer the question. Okay, are we okay with this? Okay, all right, so let's move to the next one. Problem 72. Telephone numbers in United States begin with a 3-digit area code followed by 7-digit local phone number. Okay, so we get that. 3-digit area code followed by 7-digit local phone number. All right, let me give you my number. It's a 508 3-digit area code 929 and 8726. This is my office number. Okay, 7 digits, right? 7 digits of the local number. So the question says the area code and local number cannot begin with the 0 or 1. So this too has a restriction. The first digit of area code and the first digit of local number has a restriction. Everything else, we don't have a restriction. Okay, for example, we have college number here, 8,000, 929, 8,000. This is a general Worcester State number, right? 8,000. All right, so let's see how many different telephone numbers are possible. So I'm making into the groups. So 3 digits for area code, 7-digit, 3, 4, 5, 6, 7 for the local number. There is a restriction of first digit of area code. It says it cannot begin with a 0, 1. So I'm looking at all single digit of local numbers. So single digits, okay, are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the single digits. Those are the single digits, okay? Single digit numbers. I cannot begin with a 0, 1. So 0, 1 has to be out. How many ways I can pick? Any number other than 0 or 1. There are 8 numbers that I can pick. Same thing for my local number, first digit of local number, I have 8 choices. Okay, but remaining numbers, so for example, here, I can pick 0. You see that? Here's a 0. I can pick 0. And something like a 215, I can pick 1. Doesn't really matter. So in the second digit, okay, of the area code and local number, I don't have any restriction, meaning I can have all these digits. There are 10 of this. Third digit, I don't have any restriction. Same thing for local number, there's no restriction. I can repeat 2. So yeah, I have a 9 here, I can repeat 9 again. Here's a 0, I can repeat the 0 again. You know what I mean? So there's no restriction on the repetition. Another way to say, I pick 8, I can still pick 8. Okay, so other restriction says once you pick a number, you cannot pick the same number again. So no repetition. But here, there's no restriction. What do we do with these numbers? Fundamental counting principle says you multiply this. A lot of numbers here. Okay, so 8 times 8, 64, followed by 1, 2, 3, 4, 5, 6, 7, 8 zeros. So 3, and then I put comma 3. 640 million numbers I can have. Okay, 640 million numbers I can have. The next question is this enough? Okay, maybe. If not, then we add the digits here. We add the additional digit. Okay, so each of you have a cell phone. That's a lot of numbers. Okay, so each of you have cell phone. You have a house phone. Okay, you also have a fax number. You have office numbers. So I have like 4 different numbers for myself. So I have my cell phone number. I also have a home line. I also have office number. I have fax number. It's a lot of numbers. Okay, so if we are needed not enough, we add 1 more. Not enough, we add 1 more. Things like that. Okay, so some country, instead of a 3-digit local and then followed by 4 digits, some country has a 4 digits followed by 4 digits and things like that. Things happens. Okay, we add more digits so we can have enough numbers together. Any questions on a fundamental counting principle? Now here's a one question. So what if I said, okay, so here is a number I picked 9. I can pick again 9. Here's I pick 8. I can pick again 8. What if I said no repetition? Okay, no repeat. If I pick one number, I cannot pick the same number again. So no repetition. And then guess what happened? So things changed. Okay, things changed. Okay, so if no repetition, then we have to understand some of this, the computations in here. So I want to go over. Okay, so let me see. What is the easiest way you can think of this repetition? Let's see. So suppose I have, okay, instead of doing this, okay, so we understand the problems, 72, 73, and so on. We understand this problem. Instead, okay, suppose you have 5 books, okay, in a shelf. We want to pick all 5 books to the vacation. Okay, so pick all 5. Okay, in my book, okay, in the back. How many ways can you pick all 5 books? Okay, now, so here is 1, 2, 3, 4, 5 books. So there are 5 books. Let's say A, B, C, D, E. Accounting, biology, chemistry, the drawings, and economics. So I have 5 books. Okay, how many ways can you pick all 5 books? So if I pick one of those books, so I have 5 books here. I have 5 ways to pick the first choice. So I pick 5 books, put in my pocket here, put in my bag. Okay, so if you pick one book, for example, I pick drawing. How many books left on the shelf? There are 4 books. You cannot pick the same book again. So once you pick in the bag, you don't want to take it out and then place back and then pick again. Okay, so there are 4 books left. Okay, so you pick another one. So there are 3 books left. So you pick another one. And then 2 books left and then 1. What do we do with this, guys? We are multiplying. So in here, there's no repetition. You understand this? There's no repetition. So instead, okay, there's no repetition. I have, okay, let me change the question. Suppose I have 200 DVDs. Okay, 200 DVDs. I want to select, okay, I want to select this is bad choice. Okay, so I don't want to do this one. Suppose you have 50 students. Okay, I want to pick a 3 students for, okay, student government association for those officers. So president, vice president, and treasurer. I want to pick 3 students out of this 50 students. All right. How many ways can you pick 3 students out of 50 students for student government association? Let's do this one. So here is 3 choices here. So I have 3 students. There are 50 students. It's a number of students there. I want to pick one of them as president. Okay, where we voted. Okay, presidents. There are 50 students. You pick presidents. There are 50 ways to choose presidents. 50 ways to do it. You pick one. Okay. The next one, I also want to pick another position, which is a vice president. You already picked one. There are only 49 students left. So there are 49 ways to choose a second position. So already 2 are on the side. So Leslie and the Micah is on the side. Okay, there are 50 students. We take 2, there are 48 left. So there are 40 ways to choose for the third position. No repetition, no repetition. Do you understand this? Is you cannot pick the same students. So right here, you multiply right here. So this is the next topic. This is the next topic, that what if we have no repetition, and we are going to do with this new notation. It's called a factorial. It's called factorial. And we cover this next time, okay? It's just too much for one day.